Good evening, gentlemen. Tonight's presenter is Dave Giddings, and Dave and I have known each other for a number of years, as he also served in the Royal Australian Navy and started as an apprentice marine technician. After 22 years, Dave finished as a warrant officer, and the experience and skills that he gained provided him with a great love of steam and a healthy respect for the sea. During his shore postings in the early 80s, he learnt to sail, and that ensured that he maintained some salt water in his veins, and also developed a love of mucking around with boats, as Dave has put it. And he's currently, or has been for quite some time, the owner and operator of a Clansman 30 since 1994. And I believe that that's Dave's yacht in the bottom right-hand corner of your screen there. Anyway, on retirement from the Navy, he came across the BoatCraft Pacific products, which are based on current technology, chemicals, and are safer and easier to use by both amateurs and professionals alike. Dr. Bruce McConkie developed the full range of adhesives and coatings for building, repairing, and restoring boats from modern composites to 100-year-old plus vessels. The bonus is there is no dangerous goods, and the product range can be sent by post or general courier anywhere in Australia or overseas. Drive Marine Services, which is Dave, is morphing into BoatCraft New South Wales to better reflect their diverse product range. And Dave is also a YouTube star with his channel, The Epoxy Guru, having over 190 videos posted and in excess of 1,300 followers. Ladies and gentlemen, I'll pass you over to Dave for the presentation. Thank you, Dave.
Thanks, Greg. Great intro, mate. I've been looking at an environment to present the BoatCraft products to professionals for years. We're probably the leading supplier in Australia through BoatCraft for epoxies and marine coatings, but when it comes to the professional world, it's a different story. I go into boat yards and they all want to say, I've been and done it this way for 20 years, mate. Why would I change? The reason to change is that these coatings and adhesives are a lot safer to use. And I push it very hard because I've got stuffed sinuses. As a young bloke in the Navy, we were sent in to paint out tanks, things like Coralline Black, and I just forget the Silverine product we used to paint out feed water tanks. And we used to do relays of 15 to 20 minutes at a time and come out as high as kites. As a result, I suffer every day with sinuses. So I don't want to see people go through that. And I used the Aquacoat many years ago when I had a very poor opinion of water-based paints. And I couldn't believe how tough this stuff was and how easy it was to apply. So that's where I started out, and I've interacted with Ian for probably 18, 20 years now, and Dr. Bruce a bit before that when we first took it on. There's a complete range of products, anything from resins to laminate, seal, glue, you name it. And timber, plywood, we do some of the best plywood you'll find in Australia through the Mauritius range of Gaboon. So there's a full range of products to play with. What I'll do, I'll go through coatings first. I'm not going to dwell on polyester resin or vinyl ester resin at all in this, but the slides will be there if people want to review them down the track. My old girl Silvara there on the right-hand side, she's 50 years old this year, and I reckon she'll be around for another 50 years as long as she doesn't get neglected. She's still as solid as, even though I reckon I've got 2 hulls, and I'll go into that in a minute. So what we'll mainly concentrate on tonight in boat building resins is the epoxy resin, and a bit of a comparison between old technology, new technology. I've also got a series of articles that have been published in Australian Amateur Boat Builder and more recently in Australian Woodworker. So if you want any articles, just let me know. I don't put them on the website or out for open source because they've been published through a magazine, but readily available to give them to you if you want. So polyester resin, it's a great material to make things with. There's no argument at all there. And, you know, my boat is testimony of it. One of the problems, but, is osmosis, especially in the early days. And that photo at the bottom right-hand corner is a classic example of the sort of osmosis I get on Silvara. It's always in about 5 mil deep, and it doesn't break the skin. It just grows and grows and grows, and it'll get bigger than a saucer if you let it go. Hit it with an angle grinder, and all this black crap comes out at you. Once you get under it, once you grind it back, it's shiny underneath, which means I reckon what they've done, they've built up about 5 mil one day, and it's got hot, so they've walked away from it. They've come back instead of the next day. I reckon it's come back on Monday, done no preparation, and just went lathering more resin on, and it's delaminated. It's just sitting there. So I've got 2 holes in my Clansman. Not a problem. They're built so solid that it won't hurt it. Its disadvantages, they're all there. You can read those down the track. I won't go into them in this because I've only got 45 minutes. Vinyl ester, again, it's a crossbreed between epoxy and polyester. Its biggest problem is it's an unstable resin. And if you have a look in the photo on the screen, that's a modern caravan skin. They do a lot of caravans these days in vinyl ester resin, but you can see the weave through it. It readily shows up the weave, and that'll change depending on the environment it's in. So that's one of its major problems. It's a lot more user-friendly than polyester when it comes to making composites, but it's still got its limitations. Epoxy resin. I've put BoatCraft up there, but this is a general spiel on epoxy resins. The reason they now use them in aircraft manufacture is very very low weight to strength ratio. So you get a lot of strength with minimal product. So you make things a lot lighter, and massive great structures like wind turbine blades, like that one down the bottom there, and it can handle flex. It's the ultimate man-made adhesive we've got if it's high solids. As soon as you start introducing solvent into it, it cuts down on its strength. And excellent moisture barrier, again, all your high solid stuff. And your marine epoxies, they've got a degree of flex, and the BoatCraft in particular has been made so it can handle the flex of plywood. You can put it on both sides of a thin piece of plywood, and you can still twist that piece of plywood and it won't crack. It's an amazing product, and it's right up there on the strength. It's about 48 MPa from memory. Some of the problem is when you go a bit higher in MPa, in your tensile strength, it starts to get brittle. But head and shoulders above epoxies that are made for holding bolts in concrete and things like that. Epoxy will stick to pretty well anything but your polyplastics. And even then you can cheat if you want, but don't. It's not worth the heartache. And the big advantage we've got with BoatCraft over most other epoxies in Australia is the modern technology chemicals in it. The resin's not the problem. Resin's a fairly benign thing and they're all very similar, except for additives for strength and flexibility and all that. Where the problem is in old technology hardeners, the molecules are very, very small, readily penetrate your skin. Either I better move on a bit, hadn't I? Sorry, I got a bit ahead of myself. The disadvantage with epoxies is they've got no UV resistance. And a good example is a concrete swimming pool that's been painted out with epoxy. If it's been there for a while, it'll be nice and bright below the waterline. Above the waterline, it'll be all chalky. That's the UV getting to it. UV breaks down the molecular structure of epoxy if you leave it to it. Fine, as soon as you put a coating over it, you know, and polyurethanes stick very well to epoxy. And you can't use it like you would with you playing with vinyl ester or polyester. It becomes very expensive. Another one to keep an eye on, it is coming into winter here, but epoxies have only got about a 50 to 55 degree deflection temperature, heat deflection temperature. So if you make something out of epoxy at 10 degrees C, around 60 to 65 degrees C, it's going to start losing some of its strength until you post-cure it. And what that means is if you build a boat in the middle of winter or a doohickey, whatever it be, and after it's spent a day out in hot summer sun and it raises the temperature up, that brings up its heat deflection temperature, and you can get the heat deflection temperature up towards 85 to 90 degrees C without too much trouble. But it's something you need to be mindful of, and especially when they work in very cold conditions. These are customer jobs. Unfortunately, because most of our stuff is in the retail area, the amateur boat builder side of things, they're usually individuals doing their own boats. So this one here's a 40-odd foot feeling plywood structure on frames, which is what you saw in the previous ditty. And these frames up there on the left-hand side. Over to the right, it's a bit of a passion of mine. I've set up a canoe where you can build it in a week, and it revolves around the boat coat and stitch and glue. And this here's a bunch of kids down at Eden. They've set up this boat building program for disadvantaged, disabled, disengaged students. Most of them are with an Aboriginal background down there. Because they've got real issues in the community. And this Anglican priest I know, he's gone down there to work with Aboriginals, used BoatCraft for years and understands why you should be using it. So he took it down there and he asked me if I could come and help them show them how to build a canoe in a week, and they did. And the second week they painted them. That's the first lot on the trailer. And then they took them paddling, and they've got money these days out of the Bushfire Recovery Fund, and they're into about their fourth or fifth session with kids, and it's been a great success. COVID slowed it down a bit, but that's all right. So back to our disadvantages of old technology epoxy. Sorry, I jumped the gun. They're notorious for making people hypersensitive, and the reason is the molecules used are a lot smaller than the pores of your skin. And I've got it on the next slide. I might jump to it and then come back. So it's all the chemicals in the hardener are the problem. A lot smaller than the pores of your skin, and it readily vaporizes. So it's known to cause eye issues. If you see someone working around the waterfront and they've got a swollen eye or swollen eyes, almost guarantee they've been sensitized by epoxy. And what it is, it's very corrosive, and the molecules get in the eyes, you breathe them in. And I have these blokes working around the waterfront say, nah, doesn't worry me, mate. Been using it for 20 years and haven't had a problem. And I know a boat builder who started out at the age of 14 building boats with his dad. The last time he used old technology epoxy, and I'll show you a ditty of Alf in a minute, he ended up in bed for 2 weeks, and they said, you go back near that stuff again and we'll be putting you in a coffin. The other one is it clings to clothing. So you should always have disposable overalls on and a P2 respirator when using old technology epoxies. It clings to clothing and it can last on there for a couple of hours. So if you work in an area and you walk off, go and get lunch or something, and someone's already got sensitivity, you can cause issues with them. And I've heard of that happening. Just back to a few other points. Old technology epoxy hardeners should be classed as DG8 if they're not. I think you'll find most of them are. They're very, very corrosive, and they shouldn't be sent by general courier. And they also suffer amine blush readily, especially when now we're coming into winter, and especially a bit of moisture in the air as well. And the other another issue is mixing ratio. You've nearly got to use pumps or scales to make sure you get your ratio right. Too much hardener, you send it brittle and it reduces its strength. Not enough hardener and it'll stay a sticky mess for life. And by the way, that'll still happen with a 2-to-1 mix if you've got people guesstimating as well. But they're usually 3-to-1, 4-to-1 or 5-to-1 mixes, but not necessarily so. All I can say is if you're using old technology epoxies, you're a thrill seeker. Modern technology epoxies, they're normally a 2-to-1 or a 1-to-1 ratio. Not always, but usually they are. They've got a very low vapor pressure, so that it doesn't readily vaporize. You could use BoatCraft in the office where I am now, except I've got a heater going, and it won't vaporize. It's got to get around 50, 60 degrees C before it starts to vaporize. The molecules are a lot larger than the pores of your skin, so it won't go in through your skin. And every time someone's telephoned me with a problem with skin irritation, it's invariably been they've been washing themselves with solvent. So I haven't come across one person yet that can't use the BoatCraft. Safe and easy to use, yeah. We're going to run out of time. Oh no, we've got a bit of time yet. Sorry, I'm pushing ahead fairly fast. Work health and safety. Even with the BoatCraft, always work in a well-ventilated area. We always work under my house in the garage, doors open, so you get good airflow going through. You know, don't stretch the friendship. And you should always wear gloves and safety glasses. It can still cause eye irritation if you get BoatCraft in your eyes. Don't muck around with it. And never wash off a solvent. Leave that for cleaning your tools up. For cleaning you up, clothing and skin, use some white vinegar. White vinegar breaks down the molecular structure and you can wash it off with hot soapy water. And I've already covered the disposable overalls and P2 respirator, the old technology stuff. So you don't need to wear a respirator with the BoatCraft, but be careful, don't heat it up. I read an article once about this boat builder down in Tassie, how he gets his epoxy to flow in winter. as the boys arm themselves with heat guns, and they warm the resin up as they go. They're inside this boat hull with old technology epoxy, and they improve its viscosity by heating the stuff up. What's that create? More vaporization, and absolutely no good for you. Solvent-based epoxies, one of my pets. You would have all heard of Everdure. There's a few others. Wattle's got one. Norglass have got one. I think they've nearly all got a solvent-based epoxy. You're paying a premium for solvent. Most of them have got 60% solvent. And the worst part is it's usually toluene and xylene, and they're no good for your health. They're known irritants. And what it does, the solvent molecules are a lot larger than water molecules. So by having that amount of solvent in there, that's got to leach out for the epoxy to go off. And it leaves the epoxy porous. So it cuts down, it cuts down on its water resistance and its strength. A good example of shown here is, I was talking to Dr. Bruce, the fellow, the brains behind the BoatCraft a few years ago, and he said, just tell them they're pissing money into the wind. I said, that's all right for you, Bruce. You've got a PhD behind you. I'm just a mug at this. And he said, I'll sort it out. So next thing you know, there was an article come out and Bruce had written it. And what he'd done, on the right-hand side, you'll see toilet roll tubes. They've been painted with epoxy on the inside, and he did BoatCraft and he did West System, glued down on a bit of timber that's already been sealed with epoxy. And he also did the same with, he used Everdure to start off with. And if you look at the graph over on the left-hand side, the solvent-based epoxies with the company's recommended coatings is the lower lines. And what it is, you then fill them, the tubes with water and put a lid on them. And over 20 days, the solvent-based epoxy had lost 60% of the water. It leached through the walls of the cardboard tube. The high solids epoxy, which is a line at the top, no depreciable amount of water gone. He even thought, it can't be this bad. And he got another one to compare it with. And he put extra coats on. And even then, it was still lost 20 to 30% of the water over about a month. So it just shows it's nowhere near waterproof. What we've got with the BoatCraft is a product called TPRDA. TPRDA is a timber preservative and reactive diluent agent. And what it is, it's a very dilute form of epoxy resin, and it's got some other goodies in it that help with rot issues and the ability of the epoxy to draw into timber. The reason they use solvents is that high solids epoxy don't want to draw into timber. They're inclined to lock onto the surface grain of the timber or metal, whatever you're using, and they won't penetrate in. So the TPRDA added to the BoatCraft for any porous surface allows the TPRDA to draw into the, allows the epoxy to draw into the mainly timber it was developed for densifying soft timbers like oakum and with gaboon plywood and things like that, so that you can come up with a really dense surface but maintain its strength. And the other advantage is you're starting to put down a waterproof layer from the first coat. Whereas if you use a solvent-based epoxy, you have to put a high solids epoxy over the top of it to make it waterproof. Otherwise, it'll leach water through readily. Check out the TDS for Everdure and see where it says it's waterproof. Nowhere. Next one, repairing rot. So it's quite a common thing in the marine area, especially composite boats, yachts, motor cruisers. Someone will drill a hole through, put a fitting in, and next thing they've let a whole heap of water in, and it creates issues. The epoxy is ideal for that application. The one on the right-hand side, the James Craig, her mast, bottom mast section. So your bottom mast section's iron, then the first timber section is clamped onto the iron section. And where that was done, it caused compression. The photo on the left-hand side, that's the original spar section from the forward mast on James Craig. They pulled it down and it was in pretty sad shape. Fortunately for me, the bloke they got in to take charge of it is a shipwright who'd got sensitivity, and I come across him and converted him over to our products. Cyril Humbert's his name. He's in the middle photo, top photo. He's the fella on the left. He's a Frenchman, and he'd repaired spars for wooden ships over in Europe, and they got him in to do the spar. And so what they did, they put a 1 in 16 scarf, and then bought in Oregon and glued it all together. So the first thing to do, when you've got end grains showing like the top photo there, you really need to seal it with resin first. So put it on, and then you can go to town with the 1-to-1 epoxy glue. It's a fully thixotropic glue. Where you put it's where it stays. I've seen it with gaps up to 5-10 millimeter, and it's still got full strength. So that's just the process of recovering the mast. If you look at the bottom left-hand corner, that's a shipwright by the name of Peter Gosel. They brought him in to finish it off and shaping it to get it back up on the Craig. And that'd be nearly 10 years ago now, so it's still hanging out up there. They've done the mid-mast or the main mast, and they're just in the process of doing the boom. What's happened, the poor old Craig, the Sydney Heritage Fleet's got a brilliant bunch of volunteers, but a lot of them have been builders and playing on houses and things like that. And what they've done with the boom on the aft rig, it had cracks in it. So what they do, they filled it full of Sikaflex. That's fine. It covered it up and made it look good, but it held moisture underneath it. It's now got a whole heap of rot in it. So they're in the process of splining a new section into that as well. They come and grabbed 16 kilos of glue off us a week ago now. This one here, this is just some epoxy glue projects. The one on the left was a memorial attraction down at Darling Harbour. It was built for the centenary of Anzacs. That's a 12-metre dome there, and it's got laminated plywood, double plank. It's all held together with the epoxy glue. I wish there were more projects like that come on a regular basis. They use truckloads of glue. Worked out well. So the e-glue, you can glue steel, aluminium, stainless steel. It even loves granite. So anything that you can create a porous grain surface to, or etch the surface by sanding, you'll stick it to. Aluminium, you've got to sand it and get the glue straight onto it, or you've got to use a chemical means of getting the oxidation off the surface for stainless steel or aluminium to get it to stick well, but it'll do the job. Purbon, it's a very underrated glue. It's a single pack waterproof polyurethane glue. And the ditty on the left is molds they made up at Newcastle. Are going to make their fortune making super yachts. So that's all been laminated, double laminate plywood, and it's all held together with the Purbond. They used a whole heap of staples to hold it together. Ian's bought out the Mad Scientist, had a few years back, and we've now got 3 different types. There's the original, which you got to clamp up for an hour to 2 hours, and if you want good bond, you got to tightly clamp it, no gap. And since then, there's now an F20, so a 20-minute clamp time and a 5-minute clamp time. Where the 5-minute clamp time comes in is someone doing joinery work. A classic examples, recycled timbers. We've got a mob up at Kempsey called Australian Architectural Hardwoods. They buy old bridges and warehouses, any timber structure with decent sort of timber in it, and they repurpose it. And they use the Purbond where they're putting stuff into the steam box. They can put the Purbond on a red hot piece of timber, laminate another piece to it or a dozen pieces to it. It can be wringing wet and it'll hold that shape for its life. If you get down to the new casino, the Sore Thumb down at Barangaroo, all the timber work in there, that's all recycled timber. It's all held together with either Purbond or Epoxy Glue. Acrylic, most undersold or under-respected product in the range, and it's what got me on board with all of these products. There's an Epoxy Undercoat, and it sets as tough as nails, and a 2-pack polyurethane top coat. And you put that combination over gel coat, and it gives you very good protection for a long time. What got me on the top coat was when I was playing Venture Scout Leader, we had a whole heap of old canoes the kids wanted to do up, and I wouldn't let them near solvent-based paint. So I got some Aquacoat top coat. Thought, oh, well, if it's buggered in 6 weeks' time, I'll be ready to move on to something else. And we used to take them out the Warrenora River and run them up on the sand and shells and all sorts of things. And they just wouldn't scratch. It was amazing. So that's when I started chasing Dr. Bruce to see if I could sell his U-Butte paint for him. No solvent, your solvent's water. So you thin it with water, you clean up with water. It brushes easily, it rolls easily. And if you don't use it all, you can pour it back in the container and save it for later. It's an incredible product. Bruce probably developed it 20 years before its time. It's only really starting to take off now. We get very good results with amateurs with it. Professionals, because they're used to rolling and tipping off, they struggle with it. You just cannot muck around with the top coat. You got to roll it on and walk away. If you get a run, you massage it out like you're French polishing. Once you get the hang of it, you don't need to spray with this stuff. You can get really, really good results. And after a week, you let it set. It takes 4 days to fully cure. It can look like orange peel when you first finish putting your 3 or 4 coats on. You leave it 3 or 4, you've got to walk away for at least 3 or 4 days, and you come back and you go, wow, where did all those marks go? And after a week, you can buff it like you would a car paint. These are some examples of it. Or these are all hand finishes. The one on the left-hand side's a 19-foot trailer sailor. This bloke built it, used all of our products, used white and red to paint it. His trial effort was the canoe down the bottom that his kids are laying in, and he had his young kids help him to make that boat. And I didn't have any heartache with them being there. You know, the stuff is so safe. Up on the right-hand side, the boat out in front of the Opera House, young German fella in the digital world decided he was going to get its attraction up and running, made 4 of those Glenelg speedboats. And in summer, you'll see them following each other around the harbour. And quite often they're parked on trailers out on New South Head Road, or Old South Head Road, actually. There's a clear side to it. And how you get a good clear system or a good clear finish to last any length of time out in full sun is you seal the timber right around with boat coat, and that includes bolt holes, screw holes, any penetration into it has got to be sealed. And then because the epoxy can't handle the UV, you put the clear Acrylic over it, and anywhere from 2 to 4 to 5 coats. The more coats of the polyurethane you put on, the longer it's going to last. And what that does, it keeps the sun away from the boat coat. And when you see the shine starting to dull on the top coat, it means you've got to wash it down with hot soapy water, give it a light sand, and throw a couple more coats of the polyurethane over the top, the Acrylic over the top. And if you do that, you'll get long-term out of it. The little teardrop caravan there, that was about 3 years old when that photo was taken. The top photo, right-hand side, is the tiller and seat off my boat. That seat sits out in full sun 365 days a year. And I get around 3 to 5 years out of it. I missed it last time, and the Acrylic actually peeled back, but the epoxy was fine. I just sanded back, fixed up some dings in the edges on the radius surface, threw and then threw some more Acrylic over it, and it's there. You know, you can maintain that finish without too much heartache, unlike varnish where you've got to redo it every 6 to 12 months. The bottom right-hand side photo shows you how water penetrates through an open area. Unlike varnishes and polyurethanes and other coatings, with epoxy, that is boat coat with Acrylic over the top. The grey area is where rope's been rubbing over it, and it's worn through the epoxy. But notice how the water isn't going, the moisture is going in from the open scar, not down through the timber. The rest of the timber is fine around it, but it's just working its way. And you've got to get to that sooner rather than later, because if you leave it too long, that moisture will spread along, and as it spreads, it breaks down the bond between the timber and the epoxy. And as the moisture builds up, sun on it expands and contracts, it'll break down. But that's how it breaks down. It's not going through the epoxy. Next one, Fahrenheit Rusty Metal Primer. This is an absolutely brilliant product. Again, James Craig features there. They use it on it. Where you got your any lap seam and you can't get down in between it, you just wet that out and put the Fahrenheit on, and it'll wick its way down through any seam where you're getting rust coming out of it. What it does, it converts rust, it seals it, and it primes it all in one application. So it uses 10/8 from trees to do the converting. And if you've got deep scaly rust, it even pays to have the surface wet when you put the first coat on. As it reacts, it darkens up, and you put a second coat on to make sure you fill in any micropores that mightn't have been filled the first time around. So that's how it works. It's as simple as that. And in an environment where UV doesn't get to it, you don't even need to paint over it. So inside door frames in cars, down in bilge areas, things like that, it's brilliant. The photo left bottom is one of the old Navy tugs that the Sydney Heritage Fleet's got now. They're recovering all the deck using the Fahrenheit, and then another product we got called Tread Grip. The centre top photo is the crane stores lighter they had at Garden Island. What had happened, they'd put a 2-pack epoxy undercoat on, then an epoxy top coat, and it was too tough. And when they put heavy loads on, like ammunition and large drums and other goodies, the deck would sag a bit. And the epoxy would pull away, the top coat would pull away from the undercoat. and it was turning into a rust nightmare. They treated the rusty areas with Fahrenheit rusty metal primer and then put tread grip straight over it. I'll talk about tread grip in a minute. Another good application is keels, cast iron keels on yachts. They're notorious for being all rusty or rusting through. You'll solve that by just taking the coating off, get some Fahrenheit into it, and then undercoat it, top coat, and away you go. And you'll solve the rust problem in yacht cast iron yacht keels. Few others on Fahrenheit rusty metal primer. Great around marinas. The top photo left hand side, that's the Legacy Marina down at Rustcutters Bay. They've used Fahrenheit extensively in underneath. They put steel girders on in underneath it, and then concrete on top, and it gets rust in between the girders and the concrete. Just spray the Fahrenheit in there, the rust's gone. The next one over is a pile, been damaged or it was defective during manufacture. Cut it back, Fahrenheit it, and then we've got another product called Ace Epoxy Mortar. Then over the top, that's at Royal Prince Alfred Yacht Club. I saw it about 18 months ago, and where they'd repaired was still in good nick, but what's happened is starting to go top and bottom. They didn't take the concrete back, and because the alkalinity of the concrete has dropped back where the water's got into it, it's allowed rust to get in there. So they really, when you do any repair like this on concrete with Rio, you've got to cut back until you get back towards good steel, because if you don't, that means if there's rust there, it means the alkalinity's dropped down, and you've got to get past that point to solve the problem. Same on the pontoon deck here. You just chip it out, break out the areas and chase back until you get reasonably good steel, and then the Ace seal it with the Fahrenheit, and then Ace mortar over the top of it, and you've got a reasonably successful repair. You might find you'll have problems adjacent to it down the track, because if the alkalinity's died in the concrete and the Rio's too close to the surface, the damage or the rust will come back further down the track. This is that same keel you saw before. We've got a really neat paint stripper called Lemon Peel. It's one of few in Australia that's based on NHP from memory. Ian might correct me down the track, but it doesn't work like your caustic paint strippers. You put it on, and the middle photo shows plastic has been over the keel. So we had the rusty area, anti-foul on the left-hand side, painted the lemon peel on. You put it on about 0.5 mil to 1 mil thick. Ideal way to put it on something like this is roll it and then cover it in plastic. And as long as it stays damp or wet to damp, it'll keep working through multiple layers of paint. So it comes into its own for removing anti-foul off. Also lead paints, with heritage environments, really comes into its own in those environments. And it's not overly expensive when you put it up against soda blasting and other techniques. And the right-hand photo is the keel when it's been undercoated, ready for a top coat. Yeah, and that was done in 2017. And I haven't heard from him in the last 12 months, but about once a year he reports in to say keel's still going good. Here's the tread grip. It's a single pack copolymer acrylic. You put it on quite thick. It's got synthetic rubber in it, so it doesn't get hot like your silicates types. And it on the crane stores lighter, the advantage it had there, it can handle the flex of the deck when they put heavy loads on it. So even though it damaged when they scraped heavy pallets and that across the deck, was easy to restore. All they had to do was wash down with hot soapy water, throw some fresh tread grip on, and the surface was restored. If there were any rust spots come up, they just needled the area back, Fahrenheit on it, and then the tread grip back over it. The orange deck plates down the bottom, that again is tread grip. It's just been done with a special color they want, and it brightened the engine room up. They were steel deck plates, and they're the most horrible thing going, rust brown. Again, converted the rust with the Fahrenheit rusty metal primer, then the tread grip over the top. You can put it straight onto concrete, polyester resin, gel coat, not a problem. That's the yacht on the right-hand side. That's the grey areas have been done with the tread grip. And that's basically us. You'll find me around doing videos, and that is the Epoxy Guru. But as of today, I'm retired, and I'll step back from the day-to-day side of the business. There's some other products that are here on the right-hand side. We do some oils and the System 3 out of the US. Copper boat, it's as good as any of the epoxy-based anti-fouls. I've seen it. It works really well on boats that are underway all day, every day. No reason why you can't get 5 to 10 years out of it. No good in Sydney Harbour with yachts that sit on moorings most of their life. Rush Cutters Bay, it's absolutely terrible. The white worm absolutely loves it. But when you can get in fairly clean water, they get good results up around Lake Macquarie, other waterways where they haven't had too much trouble with pollution. And on the left-hand side, the Lucy Clear range of products as well. They're specially made for woodworkers. They're a new range of products that have been bought out in the last 2 or 3 years and kept us busy during COVID when other companies were struggling to make ends meet. We were going flat out with that product. It was amazing.